Right now we're looking at lesson 1-2, drawing and interpreting pie charts and bar graphs. We see our learning objectives across the top, analyze some personal time management. We're going to have a lab on that. You'll see it's on the last page of these notes. We're going to solve some problems with percentages and look at pie charts and bar charts. So what's a pie chart? Pie chart is a circle. It's just a fancy circle. There's really nothing else to it. And that circle is going to be split up into percentages. Now remember from geometry way back when that circle consists of 360 degrees. So whenever I go to make a pie chart, I need to know what percentage each category that my pie chart represents takes up, right? So for this example, below we have a question from the USA Today survey that says, how often do you wash hands after using public restroom? This title was before 2019-2020, so I imagine these are different now. But we have 70% said always, 29% of people said sometimes, and 1% said never. And then really guess there's no other answer except for I don't use soap, but I do rinse. But that one's not on here. So we have three categories: always, sometimes, and never. So those are our answers. And the last question is, if I had the data, if I knew that it was 70% always, 29% sometimes, 1% never, how can I use, or how could I create this circle? How could I create this pie chart? Well, the way you do it is you take those percentages and you determine, okay, if 70% of people said always, how many degrees of that circle are taken up by that? So how do I figure that out? Well, it looks a lot like what we've done in the last section or two, right? So for always, we have 70% results, right? So for my circle, I need to find 70% of 360. Familiar? Yeah. 70% of 360. 0.7 times 360 is 252 degrees. Sometimes it was 29% of people. So what's 29% of 360? 0.29 times 360, which is 104.4 degrees. And then never, 1% of people polled said never. So what's 1% of 360? Don't forget, when you go to convert that percent to a decimal, it's going to take two places to the left, which means I'm going to go to the left of the one just in one, then I got to go one more space. That empty space does get filled in with a 0, because if you don't, then you'll actually end up with 10%, 3.6 degrees. So if I can figure out those degrees, and then I can get a protractor, or you'll see on the next page, I have a circle that's already pre-cut, I can then use those numbers to create my pie chart. All right, so let's get into that. First step, if you're going to do one of these pie charts, figure out your percentages, multiply them by 360. We've already seen that. And then for us, an initial boundary line is going to be at 0 degrees. We're going to talk about 0 degrees being just a vertical line at the top. So let me just scoot down and show you what I mean. Go past that. Here's 0, 90, 180, 270. This is the 0 degree mark. And then what you're going to do is sweep out whatever percentage you need for the first category, then sweep out the next percentage for the second category, and so on. So next, get your new starting boundary, add those degrees, get another boundary, and then we'll just continue doing this until we've got all the categories. So let's look at an example, because those directions just by themselves in theory don't really help out. So let's take a look. There we go. So yeah, those numbers, just like I said, they don't make sense on their own. So let's just deal with this survey. So I asked 20 students, how do you feel about math in general? And survey came out like I thought. 2 people said they love it, 3 liked it, 5 said take it or leave it, I don't really care. 6% of people don't like it, and 4% of people hated it. So those are my 5 categories. And then at the bottom, I have figured out how many people there were in total, or how many responses there were to my survey in total. 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 6 is 16. 16 plus 4 is 20. So yeah, just total responses is not its own category. So if I'm going to do the math that I just talked about, I need to figure out what percentage of my survey, what percentage of people said they love math, they like math, and so on. So I'm going to come down here and do that. I'm just taking this table and bringing it down here. So love it, 2 people said that. So if I want to make this a percentage, what do? Well, I can do, remember, fraction to decimal, decimal to percent. So if 2 out of 20 said they love it, 2 divided by 20 is 1/10. And then 1/10 to a percent, 2 places to the right, add the percent sign. So I get 10%. And then the degrees. Okay, well, love it is going to take out 10%. It's going to take out 10% of my pie. So that means 10% of 360, which is 36 degrees. So let's do the same math on the next one. 3 people said that they like it when they're talking about math. So that's going to be 3 divided by 20. 3 divided by 20 is 0.15, which is 15%. And then if I'm going to come out here and figure out what number of degrees is this going to take up, then I just do 360 times 0.15. And I do want you to see the math that we're doing. 360 times 0.15 is 54 degrees. All right. And then if we do this for the rest of them, next thing I'm going to run into, I'm just going to do some copying and pasting to help with the formatting. Swap out this 3 for a 5. 5 out of 20. 5 divided by 20 is 0.25, which is 25%. 6 divided by 20 is 0.3, which is 30%. And then 4 out of 20 said they hated it, and that's 20%. So what does the math look like? I'm doing the copy and paste here just to make finding that degree symbol a whole lot easier. 25% of 360 is 90. 30% of 360 is 108. And then 20% of 360 is 72 degrees. So if I did this correct, all of my percents should add up to 100, and all of my degrees should add up to 360. Does that work in this one? Yes. 10, and I like doing the round ones just to make it easy. 10 plus 30 is 40. 40 plus 20 is 60. 15 and 25 is 40. 60 plus 40 is 100%. 13. Where did 13 come from? 36 plus 54 plus 90 plus 108 plus 72. Let's make sure. 36 plus 54 plus 90 plus 108 plus 72 equals 360. So we did it right. Now, how do I do this on a chart? Or how do I make this pie chart? I'm going to zoom out just a little bit so we can see all of this on one page. And I'm going to show you what I mean. So I'm marking out my 0 at the top. So this will be my first line at 0. And then, well, as close to 0 as I can get. Yeah, it's not gonna. All right, so we'll just do it. We'll draw by hand. So I start at 0 and I need 36 degrees to sweep out this part of the class that said they love it. So I'm gonna make myself a mark here at 0. And then each of these dashes cuts it up into 10-degree segments. So that's 10, 20, 30, 35 would be in the middle. So just to the right, that's 36 degrees. So then I'm writing on a tablet, so it's hard for me to draw a straight line with the actual pen. So I'm going to start right here, come down to the center. And again, you can see how I'm bouncing a little bit. That's just going to make drawing a straight line for me a little tougher. You would do this on a piece of paper by hand. Yeah, you can see what I mean with the problem, right? I can't land that directly on top for some reason. So yeah, there's the line, 0. There goes me, not doing what I said. Let's get rid of that, that's just a mess. So this section from 0 over to 36 is the love it category. All right. So next, 54 degrees. 3 out of 20 people said they liked it, so that's 54 degrees. Where does 54 degrees land? Well, I'm not starting at 0 because this part's already taken out. So how do I mark out 54? Okay. Well, that is hideous. Do as I say, not as I do. Please make sure you use a straight edge there again. It's just because I'm using this tablet that I can't really do exactly what I'm saying. So if I want to go 54 degrees further, well, I'm starting at 36. So if I start at 36 and I want to go over 54 degrees, where do I land? Oh, I land on 90. How convenient. All right, so my next line is going to be at 90, which is right there. Oh, that one does line up nice. Excellent. All right, and that wedge or segment is going to consist of what group? Ooh. This is the, I love it. This is like it. I was trying to figure out the other place I've seen this, and I realized it's Cold Stone, the like it, love it categories. So if I follow that process along, the next one, take it or leave it, it's 90 degrees. So that is going to cut where? Well, if I'm starting at 90 and I want to go 90 degrees, that's going to land me at 180. So all of this wedge is going to be the take it or leave it. And then the next one is going to be the don't like it. So that's 108 degrees. So 108 degrees from 180. 180 plus 108 is going to take me over to 288. 288 is going to be where? There's 270, here's 280. This is 290, so we're going to be somewhere in there. And let's see if I can pull this off without messing it up too much. That's not bad. This is the don't like it. And then the last group up here would be the hate it. And we can check if we did it right, because what's left from 288 to 360 should be 72 degrees, and that's exactly right. So this was like it. This was take it or leave it. So that's the red. Yes, I'm getting, Larry. No. I think you get the idea here. So yeah, this whole part of the wedge is take it or leave it. And then the don't like it, get you up to here. And then we said this was at 288 degrees. I just want to make that mark so that you can see how we arrived at the answer. And then the last group was to hate it. And that makes up this portion. So there we go. It's not pretty by a long shot. If you use Excel to create the pie chart, it will come out to be better. You know, each of those will be the same color. You won't break any lines. But you can see that I've already got a problem here. And it's one of the reasons that pie charts aren't used all the time. One, printer ink is really expensive. And if you want to do a pie chart, you need to use color or some kind of patterns. It just takes a lot to make a pie chart. You saw how much time that took us to do as well, and some extra calculations. So we can do it. I want you to be able to do it. But I also want to make sure you understand that this is not the most efficient way to represent data. Another reason for that is when you use a pie chart, we don't think about this, but we're actually looking at two dimensions, right? This pie has height and width. So it's not just a one dimension of measure that I'm having to consider. I'm having to look at what is the volume, or what's the area this wedge takes up compared to the area of this wedge. Is this first wedge here of love it, is this half as big as the second wedge? Is the like it twice the size of the love it? And then as we go around the chart, we can see it's kind of hard to compare. Now these are all fairly far apart, so it's pretty easy to see which one is which. But if you had some of these numbers and each of these are at least 5 percentage points apart, but if I had some that one was 78% and if one was 19% and one was 21%, and you drew it and you didn't have a easy legend to read, it would be hard to tell just by looking at it which one is which. So that is why I'm a big fan of bar charts. So I'm going to show you an example of where sometimes a pie chart would be a good idea because of the way the problem is set up. Sometimes a bar chart would be a good idea. And then sometimes pie charts and bar charts don't work for certain questions. All right. So here is the first. This is from the 2016 election. These are surveys taken before. And we have, who do you plan to vote for? And we have our candidates. We have Clinton, Trump, Johnson, Stein, and then undecided. And you can see these numbers, they're laid out. That pie chart works out just fine. The next question was, which of the candidates do you consider qualified? And we see Clinton at just over 60%, Trump just under 40%, Johnson just over 40%, and then Stein just over 30%. Something weird's going on here, right? In this first pie chart, it was always the case in a pie chart that when I add up all these percents, I really do need to get 100, right? It would make a lot of sense if I got 100. So let's see if that happens. 46 plus 38 plus 8 plus 2 plus 6. Yeah, I get 100, right? That's everything. But what happens down here? When I add up all of these, let's just round here. Let's call that 60 plus 40 plus 40 plus 30. Something's going on. Well, what is it? It's the question that's asked, right? This first question that you ask, who do you plan to vote for? There's one answer to that question. right? It's one of these four or you're undecided. This question says, which candidates do you think are qualified? In this question, you can answer multiple people, right? You can say Clinton, Trump, Johnson, and Steiner, all four qualified. You can say that just one of them is qualified. You can say just two of them, just three of them, or all four are qualified. So when I'm dealing with a pie chart, it's nice because it's only going to make sense if everything adds up to 100. But when I bring in that bar chart, I can have things add up to whatever I want to. Sometimes it is going to add up to 100. Sometimes it isn't. But this wouldn't make any sense at all as a pie chart. So we have the question here of why did the author use a pie chart for the first question and a bar chart for the second? Because a pie chart only makes sense when it adds up to 100%. Second question does not add up to 100%. Now, I said something on the last page about how it's dimensions, how this pie chart requires you to think in 2 dimensions, whereas a bar chart does not. This is what I mean. Check out the blue and the red. Clinton at 46%, Trump at 38%. Yes, the blue is larger than the red, but not by much. Not by much at all. And it's hard to tell if you were just glancing at this quickly which one of those is higher. But look at the bar chart. It's really easy to tell which one of these is higher than the other one. And not only that, but I have 2 answers that are really close together, and it's still super easy to tell which one's more, which one's less. Johnson's over 40%, Trump's under 40%. So this is what I mean by I don't have to look at how much area does the blue take up, how much area does the red take up, and then try to compare them. All I have to do is say this bar is higher than this bar, because all I have to do is consider height. All right? So what am I going to do, or how would I draw a bar chart or a bar graph? Well, first thing I'm going to do is label. You saw that on the last page. Under each bar was the label of the category. We're going to make a horizontal chart that starts at 0 and goes up to whatever number we need. And then we're going to draw bars that have the same width, and then the height is going to be the only thing that changes. So let's dive into this question. Of 118 nursing enrollees at a college, 96 are taking a biology class, 59 are taking a math class, 85 are taking an English class, 16 a psychology, and 38 a phys ed. Draw a bar graph illustrating the data. All right, so in total, I have 118 students at the college. All right. I got 96 in a biology class, 59 in a math. I just read all this, 85 in English, 16 in psychology, 38 in phys ed. So if I want to draw a bar graph illustrating these, I need to be able to represent a number as large as 96 and as small as 16, and I need to start at 0. All right, so let's do that. Let's say this is, and it's pretty common, the horizontal line is how many students. This is what this is. All right, so 0 is my minimum, and I need to be able to represent numbers all the way up to 96. So let's just go ahead and make it 100 at the top. And then we'll try to cut that in half at 50, and then we'll cut these in half again, 75, 25. So that'll give us a place to start. Now I've already drawn some bars down here. And let's see, what were the questions? I have biology. I have, what else? I have a biology class, I have a math class, I have an English class, I have a psych class, and I have PE class or phys ed class. So there are my categories, or those are the titles of my classes. I've labeled that as classes. And then the numbers are what? The biology has 96, so that goes all the way up to, again, I can't jump very precisely because of the way this thing moves, but I can make it work. Run this up to 96. Now, like I said, I've already drawn some lines here. That's because what I did is I took this line, the width of the bar, and I copied and pasted it to make sure that each bar has the exact same width. So that's why you see these lines already drawn. Next was a math class that had 59. So we'll let that be 59. And I'm just copying and pasting the horizontal lines. Again, as a result of trying to draw this not on a piece of paper, but in a computer. English is at 85. Probably there. And let's get some lines to go up to that. And then I know that line would fit perfectly, so I just copied it and pasted it there. Psychology had 16. Halfway is 12 and a half, so let's go a little above. Okay. Copy, paste. So there's the psych. And then I'm going to make that bar again. The reason that I didn't just pick rectangles and start drawing them is to make sure my widths stayed consistent. And then for the PE class, it was 38. 38 is more than 25. It's a little bit more than halfway between 25 and 50. And we get our drawings here. There we go. Now, a nice touch for a bar chart, and you don't see this all the time, but I like this idea. It's easy to tell which one of these is the tallest. It's easy to tell which one of these is the shortest. But if you just gave me this bar chart and you didn't tell me the numbers, I would have some trouble knowing how much is each. So 96 people are in the biology class. You can write the number that that bar is representing on the top. 59 are in a math class, 85 are in English, 16 are in a psych, and 38 are in a PE class. Notice that the bars are all the same width. The distance between the bars are all the same. So again, all you have to do is when you're looking at this data set is consider which bar is the tallest, yet that's the most, which bar is the next tallest, and then you can work your way down. You'll notice again, this doesn't add up to 118 because it doesn't have to, because these are all nursing enrollees. So it's a pretty good guess that some of these are in all 5 of these classes. Some people are just in biology. Maybe some people are just in English and they're not taking any of the other 4. All right, so again, I don't have 118 is the total number of people, but each person can be taking none of these classes, one of these classes, 2, 3, 4, or all 5. So we've run into another situation where the bar chart doesn't have to add up to 100% or doesn't have to add up to 118 nursing enrollees, but it still makes sense outside of that. So next we have an application problem. Again, surveys taken 2015, 2016, and May 2015. That Institute for Public Policy released these surveys of college students. One of the questions was, do you think the following issues are or are not serious problems facing our country? Results were divided along political party for data for those self-reporting as either Democrat or Republican are illustrated with the bar graph. Now, this is a different kind of bar graph, right? This is a multi-bar graph because each question, which of these are serious problems for our country, each question is split into, did the person self-identify as a Republican or a Democrat? Red is the Republican, blue is the Democrat. So immigration policy, balancing national security with individual privacy, equal access to economic opportunity, gridlock in the political parties, cost of healthcare, and then cost of education. So we can see how some of these are more Republicans said these are big deals to big problems for the country. In some cases, Democrats said that. So the questions I want to ask about this bar chart are as follows. What issue was seen as the most serious by the most respondents overall? Okay, so across the bottom here, this is not, it doesn't say it's a percentage, so we don't assume it is. We'll assume that these are, this blue bar right here is saying 63 people said this is important that are Democrats. 42 people said that cost of college education is an important issue for that. So what I want is, I want to figure out if I take both bars from each question and I put them side by side, which bar is going to end up being the longest. And I can figure that out by just trying to ballpark these numbers. Let's say this is 63. This is 46, 39, 41, 42 maybe. This one's probably 29. This one's probably 24. And then let's look up here at the reds. So in the reds, this is 32. Next one down, let's call that 20. Ooh, that can't be 25 if that's 24. Let's try that again. That's a little too close. So let's call this 23 and call this 26. All the way back here, equal access, not quite halfway between 10 and 15, so call it 14. This one's right on the line, so that one's dead on 20. This one's dead on 30, and this one's just over 40. So let's say it's 41. All right, so those numbers are going to be helpful for us later as well. So Democrats and Republicans polled in colleges. Which one of these are serious problems for our country? 32 plus 23 is 55. 26 to 29, that's going to get me to 55. Put the next ones together, that gets me to 55. Put these together, that almost gets me to 60. This gets me to 76. And then lastly, cost of education, that's 104 total. So cost of education is the answer here. Cost of college education is seen as serious by the most overall. Anybody know why that probably happened? Okay, got to remember, who am I asking? I'm asking college students, so yeah, that makes sense, right? If you ask college students what's the most important thing, and they know they're starting to pile up debts, that's going to be an important thing for them. Next, what issue showed the greatest divide between Democrats and Republicans? Explain how you decided. So the biggest difference between Democrats and Republicans. So what I'm looking for is the largest gap between the red and the blue. And I can calculate that numerically now that I've got some numbers to represent. 63% of Democrats that took the survey said cost of education was important. 41 of the Republicans said it. So the difference between those, just subtract, is what, 22? So there's a 22 point or person difference here, 16 person difference, 19, and then we look at the one, this is probably going to be the one, right? That's the biggest difference between the blue and the red. It's 41 minus 14. 27, is that more than what we said the other one was? 63 minus 41? Yeah, It is. And we say, so equal access to economic opportunity shows the biggest divide. That's the greatest divide. That's the greatest divide. We determine this by subtracting our estimates values for each bar. And then last question, what percentage of Democrats felt like immigration policy was the most serious problem? What about Republicans? I'm going to go, like I said, percentage of Democrats felt like immigration policy was the most serious problem. Democrats, again, they did not tell us this was percentages. Yeah, they don't tell us this percentages, so we'll let them pretend it is for this question. But let's see, immigration was the most serious problem. Immigration, most serious problem, I'm right here at 23, right? So we'll let it say 23% of Democrats felt like immigration policy was the most serious problem. And then what about Republicans? Okay. Actually, that feels like the correct answer, right? 23%. So that 32% of Republicans said that 30%. Republicans. And then felt like the immigration was a serious problem. Here's the problem, though. The question that's asked gives you, it's a little too straightforward. The question says the most serious problem. Okay, take a look at that. This is the most serious problem. There's nothing in this survey, right? There's nothing in here that says each of these you can only vote for one. The question is, which issues are serious? So you can think that immigration policy is serious and balancing the national security is serious, and you can think all 6 of these are important. Not only that, but I know they didn't just vote one for each, because when I add up all the Republicans and all the Democrats, when I add up all the Republicans, I don't get 100%. When I add up all the Democrats, I don't get 100%. So while I don't love the way this is worded, we're going to get rid of the most serious problem and replace it with was a serious problem. All right. So anytime we have that language not match up perfectly, we want to make a note of it, especially for you as you're looking through these problems. Take notice of that. Don't try to run through the question super fast and just pull numbers out and be like, oh, it's math. Probably just need the number in here and I'm good. Read the question. Make sure it's asking the question you think it is. Make sure it's answering the question that you think.